Hello friends, welcome to another session. So today we are going to talk about the topic that we have discussed as part of fundamentals in the previous session, and as you know, which is very important for your any MBA entrance exams. We see questions from this topic almost every year across all the exams. Like you take CAT, IFT, TSAT, NMAT, SNAP, whatever you take, questions from this topic invariably comes in all those exams. So what we are going to discuss today is uh, inequality, inequality and modulus. So this is basically, and we have discussed the fundamentals around that. So uh, if you are first time in this channel, or if you have not gone through this fundamental session before this, so please go through that, because without that it will be very hard for you to relate and understand the problems that we are trying to solve in a certain method here. So what we recommend, or what I recommend, is please go through the fundamental session first, and I'll put them in the description box, and then start with the problem session one. Or else, if you have done the fundamentals, you know the fundamentals of inequality and modulus from somewhere else also, you can follow this. But it's recommended to go through that before. The other part is, if you know, if you are a repeat visitor in this channel, or if in case you are visiting for the first time, I'll just try to reiterate that whenever we go with a problem, show a problem on the screen, please pause the video, try to spend some time by yourself trying to solve it. And that's where your fundamental understanding will come in and get practiced. So see that for 2-3 minutes. If you are unable to solve, you can come back and continue the video, or if you are able to solve, also come back and see the approach and the solution is right or wrong. So this is one piece. The other piece is, this is problem session one. So what we do today is we will focus on foundational level problems, make your understanding much more clear and rooted, so that once we go to the level 2, level 3, or more of a level 3 problem in the next session, you will be able to in a position where you completely able to solve few of them by yourself in the first go. And like I said, we will going to solve around 10 to 11 problems in this session. But what is recommended here is, if I do X number of problem, in practice you do at least 3x number of problems. So if I do 10 here before the next session of level 3 or advanced level problems, you should be at least solving 30 problems from inequality and modulus. So this is the minimum ask from my side, so that you get used to what we're saying. I'm not extending this video for too long, so that covering every type of problem and make it a practice session, because a practice session has to be done at your own pace, uh, at your own zone, and then only you will be able to do it. So that practice session is absolutely needed. But yeah, without further ado, let's get started. So what's the first problem talking? It's talking about inequation. So if we know, if this kind of an inequality is given, we first factorize this equation: x square minus x 5x minus 24 less than equal to 0. So let's see, if I do factorization, 5x can be written as minus 8x plus 3x. Normal factorization, so x minus 8 and x plus 3 is less than equal to 0. So we can say the critical points of the roots. Critical points are 8 and 3, minus 3. So at minus 3 and 8, it will be equal to 0. So the critical points are nothing but same as roots. So what are the solutions or the roots? Solutions so will have less than equal to sign, but the roots for which this equation will be equal to 0 is when x equal to 8 and when x equal to minus 3. So then, like we did in the previous time, we'll put a number line, and let's say this is the point 0, then this is minus 3, and let's say this is 8, right? So you have these two. Now if you put, so there are three zones that is created. So let's say this is zone 1 where you have this is zone 2 where you have this, and this is zone 3, let's say this, right? So there are three zones created. Now 0 lies in zone 2. So if I put 0 in this equation, what will become? -8 into 3, so that is -24, so which is less than equal to 0, which satisfies the criteria. Now, so that means 0 is somewhere lying here. So this is 0. So 0 falls in a zone which satisfies the equation. So this part to this part. So this part basically satisfies. This part does not satisfy. This part will not satisfy. So if you take any value beyond -3, it's a -5 or -6, you see your equation will not satisfy. Even if you take more than 8, or let's say 10, you will see your equation will not satisfy. So as we know from the previous session, if one of the zones satisfies the equation, the alternative zones will not satisfy the equation. So from here we can say -3 less than equal to x less than equal to 8 should be there, right? So this is the solution. Or the other way of writing this is minus infinity to -3, where -3 is included. Or this is the union sign, and 8 to infinity. So 8 is included, infinity is not included. So this whole part is your x. So x belongs to, so this is a belongs to sign. X belongs to minus infinity to -3, where 3 is included, minus infinity is not included. That's why the change in the parenthesis, union, or 8 to infinity, where 8 is included, infinity is not included. So this is one way of writing. So this is also right, this is also right. Depends on what is given in your options, you can choose one of them. Let's move to the next one. Let's see what it says. So in case if you have any doubt or something is not clear, please feel free to drop a note in the description box, or you can drop me a mail with the mail ID in the description box also. You can drop a note in the comment section and I'll be able to respond. So this one says 4 minus x whole to the power 7. So okay, so 4 minus x whole to the power 7, x plus 6 whole to the power 9, x plus 9 whole square greater than equal to 0. So the idea here of this kind of problem is where higher powers are given, we try to take out the highest power which is even, so that we can definitively say that number, that part has to be a positive number. So if we see there is no even power of a positive or a negative number, can be a negative number. So what I say, let's say -10 to the power square is a positive number. Similarly, instead of square, if I write to the power 4, that is also a positive number. So any even power, any even exponent of a positive or a negative number has to be a positive number. So if I take it out, so this becomes 4 minus x to the power 6 is out. From here, x plus 6 to the power 8 is out, because 8 is the maximum even power I can take out in x plus 6. 6 is the maximum even power I can take out in 4 minus x to the power 7. And x plus 9 whole square is also taken out. So this is one part. The other part lies 4 minus x into x plus 9 greater than equal to 0. So that is given. So now I can say this entire part has to be greater than equal to 0, because this is positive. This is positive. Now the other part is what I need to consume. So what is the other part? 4 minus x into x plus 9 has to be greater than equal to 0. So I have to create a condition based on this section, not on the previous, not on the other section, because the other section, irrespective of the value of x, will be positive. But this section, we have to see what is the condition on which this section is positive. Because if this section is negative, if this section, this 4 minus x into x plus 9 is negative, then it will change the whole thing as negative, because my left part, so the first part, this part is positive. if this part becomes negative, that means my outcome will be a negative number, but my outcome needed here is a positive number. So what I need to do here is 4 minus x into x plus 9 has to be a positive number. So that's where we need to find out the conditions or the scenarios. So from here, what are the roots we can say? Roots are critical points. So we can say here 4 and minus 9, because these are the two values that will make it equal to 0. Again, put it in a number line. And so let's say this is minus 9, and this is a point of 0, and this is 4. So again, you have zone 1, zone 2, zone 3, three zones. So if you put 0 in this equation, it will become 4 into 9, 36. So 0 is typically satisfying the equation, because if I put 0, my result becomes 36, which is greater than 0, which is satisfying the condition. So this is a right solution zone. This is not a solution zone. This is not a solution zone. So I can say minus 9 less than equal to x less than equal to 4 is the solution. Okay, so x has to lie between minus 9 to 4, because this zone is typically satisfying the equation. Any value you put above 4 or less than minus 9, it will see the equation will be less than 0. Right? So I hope these things are clear. Let's move to the next problem. Okay, but it says x plus 4 into x minus 2 by x minus 6. So when you have, like if you remember, we said if a by b is greater than equal to 0, then we can say ab is also greater than equal to 0. How we say that? Because we multiplied b square in both sides, right? We multiplied b square in both sides. So it's not always, don't write a greater than equal to b. So that's, or a greater than equal to 0. So that's not, or we cannot say a greater than equal to 0. So we can't say all that, because this is not possible anyway. So from here you cannot say, a greater than equal to 0. For example, and I have explained this in the previous session completely, but I'm just quickly revisiting that. So if you have, let's say 2 by 3, 2 by 3 is greater than 0, right? 2 by 3 is greater than 0. Here 2 is greater than 0. So here your a is greater than 0. But if I write minus 2 by minus 3, that is also greater than 0. In this case, minus 2 or a is not greater than 0, because that's a negative number. Since you have a negative in numerator and denominator, it gets cancelled. But in itself, numerator is a negative number. So from a by b greater than 0, you cannot write a greater than equal to 0 always. What we can do at max is we just multiply b square on both sides so that it become ab greater than 0. So in this case, if you think of a as x plus 4 into x minus 2 and think of b as x minus 6, so from here, then we can write by applying the same thing that we used here is x plus 4 into x minus 2 into x minus 6 must be greater than equal to 0. So what are my roots? My roots are minus 4, 2, and 6. So these are my three roots, right? Now, if I put in a number line, so let's say this is minus 4, this is 2, and this is 6. So there are 4 zones created, 3 roots. So 1, 2, 3, 4, 4 zones created. So 0 lies somewhere here. So let's put 0 in this equation and see what we get. So if we put 0 in this equation, we'll get 4 from the first value. 0 minus 2 is minus 2, 4 into minus 2, 0 minus 6 is minus 6, so into minus 6. So that is 48, which is greater than 0. So 0 basically satisfies, right? So 0 basically satisfies this equation. Now, if 0 satisfies this equation, that means minus 4 to 2 is a solution zone, because 0 lies in that zone. So this is a solution zone. First zone is not a solution zone. Third zone is not a solution zone. Fourth zone is also a solution zone because it's alternative. So can we say minus 4 less than equal to x less than equal to 2, or we have x greater than 6, right? So, but have you seen this one thing? I have not written x greater than equal to 6 because x cannot be equal to 6, and this is the most important part of your problem. X cannot be equal to 6 because you in an actual equation you have x minus 6 in the new denominator. The moment you put x equal to 6, it will be infinite or cannot be determined because your denominator becomes 0. So this equal to sign will not be there, and x has to be more than 6. So whenever we say fourth zone is the solution zone, it will not have 6 as the solution. It will have any value higher than 6 as a solution. So be careful on what is given in the equation. By taking some value, will it hamper the fundamentals of the given equation? So in this case, if I put 6, it will hamper the fundamentals of the given equation, which is equation needs to remain, equation needs to hold true, or equation cannot be completely indefinite. So if I put x equal to 6, this becomes indefinite. So that's why x cannot be equal to 6. So this is the solution zone. So this part. Okay, let's see the next problem. So what we know here is if mod x is greater than equal to a, and if a is greater than 0, then and what can be said is x is greater than a, or x is less than greater than equal to a, or x is less than equal to minus a. So what mod typically means? Mod basically means distance. So if I say mod x, or the distance is more than a, let's say a number, let's say 10, if the distance is more than 10, then the number, or then the distance itself individually has to be more than 10. So I say in bracket, if I say mod x is greater than equal to 10, then within the mod the value has to be more than 10, because if it is 12, then only it will satisfy, or if it is minus 12, then only it will satisfy. Minus 12, mod of minus 12 is nothing but 12. So this is talking about the distance. So if the modulus of something is more than equal to a positive number, then the number has to be more than the positive number, or has to be the negative of that negative of the number. So this is a very important understanding, and we have done it completely in depth in the previous session, but just revisiting this is the condition. So in this case, we can write 11x plus 23 must be greater than 43 in the first scenario, equal to 43. So this is the scenario. So from here we can write 11x must be greater than equal to 20, or x must be greater than equal to 20 by 11. Right? In the second scenario, what we need to write, 11x plus 23 to be less than equal to minus 43. Right? It's then equal to minus 43. And from here, we can say 11x must be less than equal to minus 66. If 23 goes on that side, it will become minus 66, or x less than equal to minus 6. So we can say x belongs to minus infinity to 6. Both are included. 6 is included. Union. This is one part, and this is the other part. So 20 by 11 to infinity. So this is the solution. So minus infinity to 6, and then or 20 by 11 to infinity, where 6 and 20 by 11 both are included. So this is the solution of x. You take any value. If you put, so we can say 0 minus infinity to minus 6. So 0 is not part of this solution. So if you put 0 in this equation, you will see you will get 23, which is less than 43, which does not satisfy the equation. But if you take 10 as a solution, which is more than 20 by 11, so 10 into 11 is 110 plus 23, 133, which is more than 43. So you can take random example and see whatever solution was saying, if any value within that zone satisfying the equation or not. So that way it's a cross validation. Okay, let's move to the next problem. This is mod x square minus 9 of mod x minus 52, right? So if it is 52, and how we are going to solve it typically, let's see. Let's say mod x equal to a, right? So we can write this equation as a square minus 9a minus 52 is equal to 0. So we can just write this a square is 13a plus 4a minus 52 equal to 0, or a into a minus 13 plus 4 into a minus 13 equal to 0, just breaking the middle term. So a minus 13 is equal to 0, or a is equal to minus 4, a is equal to 13, right? So we have, now we can say a is nothing but, so mod x is equal to minus 4. Now that can never be the scenario because mod x is a distance which is always positive. So this is not possible. From here we can say mod x is equal to 13, or we can say x is equal to plus or minus 13. So this is the solution. So this is clear. So how we did it, mod x cannot be a negative number. And if you have a problem like this, you can just assume mod x is another variable and just solve this equation and then try to answer this. Okay. See the approach, how we are doing it, and that's way it will be very helpful. Now see this problem, it says if x is equal to x minus 5, mod x minus 8, and mod x minus 11, find the minimum value. So we can say your fx is equal to mod of x minus 5 plus mod of x minus 8 plus mod of x minus 11. So it's the sum of three distances. So mod of x minus 5 is one distance, mod of x minus 8 is another distance, mod of x minus 11 is another distance. Now, if you recall carefully what we said, mod of x minus a. So if something is mod x, that means it talks about the distance of x from 0. If mod of x minus a is there, it talks about the distance of x from a, right? Recalling what we did in the previous session. So mod of x minus 5 is talks about the distance of x from 5. So let's have a number line first. So let's say x is a 5, then mod of x minus 8 will be a distance of x from 8, and mod of x minus 11 will be a distance of x from the point 11. So there are three distances. So let's say distance of x from 5, distance of x from 8, and distance of x from 11. Now you have to place x in such a way so that the sum of all these three distances are minimum, right? Now let's say this is the distance is a, this distance is b, and let's say this distance is c. So what you have to do typically here is you have to do a plus b plus c minimum is what you need to find out, right? If those individual distances. Now if you think carefully, if I put, and this is a very similar problem we did in the previous session. So if I put x somewhere here, right? I'm just taking an example, x somewhere here. Then I will, from 5, this is the distance. From 11, this is the distance. From 8, this is the distance. So one thing you can see, this part of the distance or this part of the zone, what we are doing, we are calculating 3 times, for one for 5, one for 8, and one for 11. This part of the zone, we are calculating twice, one for calculating the distance from 8, another from calculating the distance from 11, because 11 has to be this big. So this part is in 11 and this part is also in 8. So we are calculating this zone twice. So this is not a very optimal way of calculating. So what we can say is, in order to minimize this, it cannot be falling beyond 5. Okay. Now see what happened beyond 11, somewhere here. So for 11, this is the distance. For 8, this is the distance. For 5, this is the distance. So if you see, this part typically gets added thrice. This section typically get added thrice, one for 11, one for 8, one for 5. Similarly, this part get added twice, one for 8, one for 5. So again, not the ideal way of calculating the distance, because you are adding the same section multiple times for multiple values. Now, the idea here is, so x has to lie somewhere between 5 to 11 to get it minimized. Now I know x lies somewhere between 5 to 11. Now let's say if x lies here. So from 5, this is the distance. From 11, this is the distance. Very good. There is no overlap zone. But from 8, there is a distance. We have a overlap zone of this, right? So, which is again not optimal, because for 8 and 11, you are overlapping a certain section of the zone. And that's why your distance, some of the distance will be more. Because for 8, you consider a certain part. And for 11 also, you consider some section of that part. So some section of the number line or the distance gets added twice. So obviously it will not be minimum, right? If I take a number on this side, it will create the same distance. For 11, this is the distance. From 5, this is the distance. From 8, this is the distance. And then this section is again calculated twice. Once for 5, while calculating the distance from 5, another time while calculating the distance from 8. So obviously this is not the ideal way. So the ideal way here is, since 5 and 11 is at the two ends and there is a distance of 6, the ideal way is if x can be equal at this zone. So for 8, so from 5 to 11, this sum will be 6. And if the sum coming from C, or the sum or the distance from X, if it is 0, then it is ideally optimized. So if X value lies here, then 5 to 8 this, 11 to 8 this. So there is no overlap. And for 8, there is no distance because it's at that point. So you can say at X equal to 8, X equal to 8, your A plus B plus C minimum be equal to 6. So the fx minimum is 6 at x equal to 8. And put the value of 8 in the given equation, you will get the value of 6. That's the lowest possible value. So whenever you get a problem like this, always try to put x. When you are trying to minimizing it, always try to put x at the third one. So there are two ends. So for the two ends, whatever be the distance, that will be the maximum distance. And that will be the minimum distance you have to consider. You can't go less than that, because from the 2 points, that two ends, that's the minimum distance when we consider the sum of all the values. And then the third value has to be at the zone where the not exactly, it looks like it's midway, but it may not be always midway. If you have x minus 8 ki jagah, if you have x minus 9 and the other two remain same, then you have to place x at 9, which is not the midway. But you have to place the x at the value which is somewhere at a middle between 5 and 11, right? So that the distance from that point to x becomes 0, because that point becomes the point where x lies. So distance from the point which is somewhere between 5 and 11 has to be 0. And then from 5 to that point and from 11 to that point, there is no overlap of a distance. And that's the way we can calculate these problems. But if you understood this by seeing the problem only, you should be able to say that at x equal to 8, the minimum distance will be created, and put the value of x in the equation, and you will be able to find the minimum value of fx. So ABC, okay, let's see the next problem. It says ABC are the sides of a triangle. Find the range of a square plus b square plus c square. So this is one piece where we have to use arithmetic mean must be greater than equal to geometric mean. So if you remember, we talk about arithmetic mean more than geometric mean and greater than equal to harmonic mean, right? So we'll use this section here. So when a problem statement, something like this is given where there is no equation, not nothing, the best way to start is arithmetic mean greater than geometric mean. So here there are three numbers a, b, c. So their arithmetic mean will be a plus b plus c by 3. Or in case, since we see the multiples in the denominator is at a 2 variable at a time, 2ab, 2bc, 2ca. So there is no 3 multiples. So in this case, if I need to do, it has to be cube root of ABC. But ABC together, we don't have anything in the denominator. So what we have to do? So we have to take two values at a time. A plus b by 2 must be greater than equal to root over of AB. So we can say a plus b must be greater than equal to 2 root AB. Or if I do a whole square, a plus b whole square must be greater than equal to 4ab. Or we can say a square plus 2ab minus 4ab plus b square greater than equal to 0. Or we can say a square minus 2ab plus b square greater than equal to 0. Or we can say a square plus b square greater than equal to 2ab, right? And from here, we can say a square plus b square by AB must be greater than equal to 2. A square plus b square by AB must be greater than equal to 2, right? Similarly, we can write from the same way we can write b square plus c square by BC must be greater than equal to 2. C square plus a square by CA must be greater than equal to 2. Let's say this is equation 1, equation 2, and equation 3. So if I do 1 or okay, actually, instead of doing this, what we can do here is we can keep it here. So a square plus b square greater than 2ab. This is equation 1. So just let me write this. Okay. So this is equation. So this is my equation 1. So the similar way, what I can write is I can write b square plus c square must be greater than equal to 2bc. C square plus a square must be greater than equal to 2ca. So this we can write. So let's say this is equation 2 and this is equation 3. So if I add, just a minute. So if I add 1 plus 2 plus 3, what I'll get? I'll get 2 times a square plus b square plus c square, because a square plus b square from first, b square plus c square from second, c square plus a square from third. 2 times of all of this greater than equal to 2ab plus 2bc plus 2ca. So how I can get what is given in this equation? A square plus b square plus c square by 2ab and 2bc plus 2ca greater than equal to half. So just bringing the right hand side into the denominator of left hand side, and multiplication of left hand side, which is 2, going to the right hand side. So this is one way. So one part we got. So this is more than half. Now says these are the sides of triangle. So I have to see what it is less than half. So is it the only condition or there are more to it? Okay. So if this part is clear, if you understood this, I will remove this and possibly do the next part in the same page. So I'll write it what we got. So I'll just remove this. Okay. So what we got from the previous one is a square plus b square plus c square by 2ab plus 2bc plus 2ca is greater than equal to half. So this is what we got. Now these are the sides of a triangle. So these are the sides of a triangle. Let's see if we can use this. So we know a plus b must be less than c, not equal to, must be a plus b must be less than c. This is one way of saying it, because sum of two sides is always more than the third side. Or the other way of saying it, when ABC are three sides of a triangle, difference of two side is less than the third side. So this is actually a plus b must be greater than c, and a minus b must be less than c. Sum of two sides is more than third side. Difference of two sides must be less than the third side. So from this, if I just make a whole square, so a minus b whole square must be less than c square. So we can say a square minus 2ab plus b square minus is equal to less than c square, or we can say a square plus b square minus c square must be less than 2ab, right? Similarly, if I write b plus c must be greater than a, or b minus c must be less than a, and again do a square root of this part, this two, so we can write the same way: b square plus c square minus a square is less than 2bc. Similarly, c square plus a square minus b square less than 2ca, right? So this is one way. Now if I add all these three, what I'll get, 2 times a square, because the sorry, not 2 times a square, you will get 1 a square, because a square will get cancelled if we just add all the left hand side, if you add all the right hand side. So your a square will here get cancelled, b square will get cancelled, c square will get cancelled. So what you get finally here is a square plus b square plus c square must be less than 2ab plus 2bc plus 2ca. So from here we can write a square plus b square plus c square divided by 2ab plus 2bc plus 2ca must be less than 1. So this is one condition. It has to be more than half. It has to be less than 1. So minus infinity to 1 and half to infinity is the solution. So this is what? It has to be more than half. It has to be less than 1. Right? Remember, there is no equal to sign when we are calculating the less than, because difference of two sides is always less than third side, cannot be equal to third side, right? Okay, but when we did the greater than part, we started with am greater than equal to gm. Am can be equal to gm also, so that's why greater than equal to. So that's why you see for half there is a greater than equal to, for one there is only less than, because we started with the hypothesis or the condition that two sides difference is always less than the third side. Okay, let's move to the next problem. What it says, find the minimum value of 2x plus 2y by 3z, 2y plus 3z by 3x, and 2z plus 2x by 3y, where x, y, z are positive number. So think on this problem. They said find the minimum value of all the sum, right? Find the minimum value of all the sum. Right, now think on this. Now if you see this number carefully, what it talks about, it talks about just a minute. So it talks about 2x plus 2y by 3z plus 2y plus 3z by 3x, or 2z plus sorry, it's not 3z here, it's 2z, 2z plus 2x by 3y. So this is given to you. Now, if you see carefully what you need to do, so everywhere if I take 2 by 3 common, or we can you can add one more step here, just keeping it simple. So we can write it as 2 by 3 or 2x by 3z plus 2y by 3z, 2y by 3x plus 2z by 3x plus 2z by 3y plus 2x by 3y. So from all of this, if I just take 2 by 3 common, you have x by z plus y by z plus y by x plus z by x plus z by y plus x by y. So you have this. So now if I just try to simplify this, this is becoming nothing but x by z and plus z by x. So this is one part. The other part is x by y plus y by x. The other part is y by z plus z by y. So these are the three ways you can write. Now, if you recall carefully, in the previous problem, in the fundamental session, we talk about one scenario where we say a plus 1 by a must be greater than equal to 2. Greater than equal to 2. If a is positive, a is positive. So if a is positive, a plus 1 by a must be greater than 2. Here x, y, z all are positive. So here, if I consider in the first case, your a is x by z. So then this first term is nothing but a plus 1 by a, because 1 by a is becomes z by x. Similarly, in the second term, if I consider a is x by y, your y by x will be 1 by a. So the minimum value is 2. So the minimum value is 2 when a is equal to 1. So from this part, we can say minimum of a plus 1 by a is 2 if a is 1. So the minimum value of a plus 1 by a is 2, and all these three are in a form of a plus 1 by a. So the minimum value of all these three will be 2 plus 2 plus 2, or 6, or 2 by 3 into 6, or 4 is the minimum value. This is the minimum value, and 4 is the minimum value of the given equation. So this is clear. So what we did, we finally firstly break down this and then take 2 by 3 common. And then what we realize is it follows the a plus 1 by a pattern. So remember, we talk about very intensely on how to find out the minimum value of a plus 1 by a, right? Okay. Moving on to the next problem. It says, if x and y are positive number, find the minimum value of. So if you remember what we also, there was one definition where we say your a1 plus a2 plus a3 plus dot 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 an is minimum when, or the other way, we said if a1 into a2 into a3 dot 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 equal to an is constant, then a1 plus a2 plus a3 plus dot dot an will be minimum when a1 equal to a2 equal to a3 equal to an. So basically what we're trying to say, if the product is constant of few numbers, few integers, the product is constant, then the sum will be minimum if all the numbers are equal. And so this was the concept that we learned in the previous session. Now here it says x to the power 4 into y is a constant. So x to the power 4 into y is a constant. Now, so that means there are 4 times of x. So can I say x into x into x into x into y, that is equal to 32. So there are 4 times of x um, into y is 32. But in the sum, I can see we have only x plus 8y, only one time x and 8y. So what we need to do, we need to break this into 4 times of x. So if I break it into 4 times of x, it will become x by 4 plus x by 4 plus x by 4 plus x by 4 plus 8y. This will become, so y once here, but here we have 8y. So in this case, we have to rewrite this x, because here, if you see, here is also a1, here is also a1, here is also a2, here is also a2. So there is no change between the product and the number that are getting added. So when I say product of a certain numbers are constant, some of the same numbers has to be minimum. While considering the minimum condition, we have to consider the same numbers ka sum. So if I considering for sum is x by 4, I cannot have x in the product. So the product has to have a x by 4. So if I do x by 4 into x by 4 into x by 4 into x by 4. So then we have multiplied the denominator with 64. 4, no, sorry, 4, 4, 4, 4, not 64, 256. But in the numerator, we also have to get 8y. That means, can I say 32 has to be multiplied by 4 times 4 is 256. Yeah, into 8. So whatever we did in the left hand side, we did the same in the right hand side. Right? So this is how much? So 32, and this is 1. So this is 1. Okay, so the product is still constant, right? Product is still constant. Now, what we need to do, the value is 1. So all of them must be equal, and all of them must be equal, and the value will still be 1 when all of this left-hand side values will be equal to 1. So if I do this, my x by 4 is equal to 1. For all the x by 4, it has to be equal to 1. And 8y is also equal to 1. So x become 4 and y become 1 by 8. Right? So the x plus 8y, which is asked in the problem, minimum when x is 4 and y is 1 by 8. So 8 into 1 by 8. So this is 5. So 5 is the minimum value. Right? So this is a very important one to understand. If the products are constant, the sum of the same number is a very important one, is minimum. So when we say first is x to the power 4 into y, so that means there are 4x and 1y. So I have to have 4x in my sum also. 4x from 1x will come only when we do x by 4 and add that 4 times. So that will have 4x's. Now, when I divide x to x by, when I change x to x by 4, then in my product also it has to be x by 4. So we change that x to x by 4 and we change that y to 8y, so that the sum, the components in the sum remains the same components in the product. So just dividing by 4 times for 4x's and multiply y with 8, I do the same thing in the right hand side and get the value. Now this value has to be constant only, this value is constant, but it will be minimum only when all of them are equal. So all of them are equal only when is possible, when all of these values are equal to 1. So x to the power 4 is equal to 1 because your product is 1. X to the power 4, x by 4 is 1, so that gives you x as 4. 8y should also be 1, so that will give you y as 1 by 8. So that's how we can do it. Okay, let's go to the last 2 problem. So from here, if I just do, so I can see A, B, C in the denominator as well. So we can write 7A square plus A plus 7 by A. And then we have 13B square plus B plus 13 by B into 12C square plus C plus 12 by C divided by 27. So from here we can write 7A plus 7 by A, 7A plus 1, sorry. A will get cancelled. So this is first part. Then we have 13B plus 1 plus B by 13 into 12C plus 1 plus 12 by C divide by 27. So just dividing by A, B, and C. Now, I mean this. So this first part become, if I take 7 common, A plus 1 by A plus 1. The next part, 13 common, B plus 1 by B plus 1. Third part, 12 common, C plus 1 by C plus 1. This whole divided by 27. So A plus 1 by A minimum value is 2 that we saw just earlier. So 7 into 2, this is the minimum value, plus 1. 13 into 2 plus 1. 12 into 2 plus 1, whole by 27, right? So the first part is 15, second part is 27, the third part is 25. Yeah, 13 into 2, 26, 27. So divided whole divided by 27. So 27, 27 get cancelled. 375 is the minimum value. So yeah, again, we applied A plus 1 by A minimum kind of a logic. Let's hope this is clear. Please feel free to drop a note if some part of the problem is not clear. So we are trying to get in a form of A plus 1 by A and apply that logic to put the minimum value. Mod 3x minus, so if we remember, we said mod x less than equal to A. If A greater than 0, then minus A less than equal to x less than equal to A. So if mod x is less than equal to A, and if A value is more than 0, then A lies between minus A, x lies between minus A to A. Similarly, from here we can say minus 23 less than equal to 3x minus 8 less than equal to 23. So if I just add 8 on both sides, it will become minus 15, 3x, then 31, right? So minus 5 less than equal to x less than equal to 31 by 3. So this is one part. This is for x, and for y it will be minus 29 less than equal to 5y minus 14 less than equal to 29, right? So again, if I add 14 on both sides, so this is minus 15 less than 5y less than 43. So divide by 5, minus 3 less than equal to y and less than equal to 43 by 5. Now what they said, maximum value of mod x minus mod y. Now maximum of mod x minus mod y, your mod x has to be maximum. So this has to be maximum and this has to be minimum. And then only the difference is maximum possible. So mod x maximum possible is 31 by 3. Mod x maximum value is what? 31 by 3. So this is 31 by 3. And mod y, so see, mod y will be maximum only when y, mod y has to be maximum when 43 by 5, but mod y will be minimum at 0, because mod y is always greater than 0. So even if you take y value minus 2, mod y give you 2. But if you take mod y value 0, your mod y will give you 0. So mod y minimum value will be 0. So your answer will be 31. This is the maximum value. So I hope things are clear. You understood how we are solving this different kind of problem. We have solved all type of problem today. Okay, and in the next session, we'll go to the level 3 or advanced level problem. So I hope this is clear. Please feel free to drop a comment if somewhere it's not clear, or drop me a mail if you want more focused session with me. But overall, I think this is helpful, and see you next time. But before that, please like, share, subscribe for the algorithm and for my own motivation. And see you next time with advanced level problems of inequality and modulus. Thank you. Bye.